Welcome everyone to the Opscientia DAO Hall. Opscientia is an open science community actively researching and developing tools for decentralized science on the web. So what is it that we do? Some of our key activities involve bridging a few key aspects of science and Web3. So this includes cloud services and requirements for open access data commons, specifically for science, research data management with decentralized file storage protocols. We're also doing some work on reputation, identity, and collaboration for research. Today, you'll learn a little bit more about Jacob's work on token engineering to build alternative systems of what I like to kind of describe it as value transfer and capture that can actually support knowledge creation systems in parallel with traditional funding schemes. And lastly, we're also we're community first, and so providing support and funding for scholars and developers, and specifically those that are in between career gaps to perform either basic research, which is going to always be very drastically underfunded until something changes, or those that are contributing to the growing DeSci ecosystem, and that's through our Open Web Fellowship program. So you can get involved today by joining a working group on Discord and any of the above topics. If you have an academic background or a little bit more senior and would feel comfortable serving as a mentor, you can join our ranks of Open Web Fellow Mentors. Just please get in touch with me directly. I can point you to the resources for that. Or if you have a really great idea, but you're not quite sure how to get started on it, you can consider proposing a research project to the community, which could be put up to votes for funding. One more big update. So before we really get into it, we've recently decided to begin collecting POAPs as a way to measure contributions within the community. So POAPs will be issued for each community DAO hall and is right now being considered as a way to signify membership and service in the DeSci ecosystem. So we can do some things that we're pretty excited about that we can't do with traditional AAAS or SFN or what have you membership in whatever professional society, because we have single sign-on with Ethereum. We have the entire Web3 ecosystem and portable reputation that can allow us to really build some interesting dynamic representations of the contributions within the community. So pretty excited about that. We're taking baby steps to get going in that direction. So you can make sure to claim your POAP by completing this survey. Give me one sec. Paste it in the chat for you all. There you go. Let me know if you have any issues accessing that link, or if there's any issues, send me a chat. So please complete the survey. It's meant to collect some information to help us distribute the POAPs. We're going to be minting one for each RSVP to the event. So please, please, please make sure you RSVP on Discord, so that way we know how many to mint each time. And if there's no questions or comments or requests for clarification, I'd like to introduce Jacob and his work today.
Yeah, thanks. So hello everyone, I'm Jakob, and today I've prepared a hopefully not that long of a presentation on my Open Web Fellowship. So let me just share my screen.
And if I may, I'd like to give a little bit of an introduction to Jacob as well before he gets right into it. The traditions of academia are hard to extinguish, right? So we always have to have our speaker intros before the speaker gets into it. So yeah, I just wanted to introduce everyone to Jacob. Jacob has originally approached me through Kernel, which is a Web3 kind of community / incubator for ideas, startups, technological innovations and solutions within, of course, the Web3 space. I was initially really kind of impressed with Jacob. He's a second year at Fordham University studying maths and physics. He has quite an extensive breadth of knowledge for his level, I think, in computational neuroscience and mathematics. And we initially really hit it off and started kind of thinking about how we can apply formal quantitative models and mechanistic models, thinking about multi-agent modeling, game theoretic equilibrium, and optimization parameters that could help us think about science in a more quantitative way, thinking about value transfer, and specifically through the framework of the Ocean Protocol, which is a data marketplace that we're abstracting to become a knowledge marketplace through this research, and specifically using the Token Spice CAD software, which was originally developed for, and Jacob is going to go into all the details, I'm sure, was originally developed for electrical engineers to optimize chipset designs, but it's a universally abstract and generic enough language that you can use it to basically to model any type of complex system with various optimization parameters. So I'll let Jacob get into it. You can find out more about his fellowship in the link here if you'd like to provide some feedback, critical reviews, or any other information. And I'm going to go ahead and let Jacob get right into it.
Yeah, thanks, Charlie, for the great intro. I don't think I've ever had anyone introduce me before, and definitely not in that fashion. Just can everyone see the screen? Can everyone? I actually can't see anyone, so I'm not sure whether you can see it or not.
Oh, you're good.
Oh, okay, cool. Yeah, so my open web fellowship is titled Simulations for Science Token Communities, and what that essentially means is that I am looking into different ways that value can flow within a science ecosystem, and then I'm trying to replicate that in code and run simulations on these token communities. So before I get to the details of the different simulations, I want to briefly go over how this project ties into Opscientia's mission to decentralize science. So one of the main problems with science in general is its value flow, so where the value flow starts at some centralized grant funding agency, and which gives grants to researchers, and then the researchers use that funding to cover the costs of their research, and then to publish to centralized knowledge curators, which in this case are just journals. So you can see that general schema on the right there, and this value flow is really linear, and it has a bunch of different problems with it. So firstly, there's very limited collaboration and data sharing between researchers, and actually knowledge sharing in general. Not only is data and knowledge sharing not really incentivized, but since researchers themselves don't really have ownership of that data, since they are usually bound by some contract that as long as they are being employed by some centralized agency, like a university or a private research group, any IP that they produce does not belong to them, but rather to the organization. So even if researchers wanted to collaborate and share data between groups, they couldn't because of some legal obligations. And another thing is that if data that should be already globally available, so data that has already been collected, needs to oftentimes be collected again because there isn't this incentive to share data. So resources are essentially wasted on trying to replicate the data that already exists, and that's really a failure in the whole scientific ecosystem. So this is the main motivation behind this project, and what I aim to do in this fellowship is to really find alternative value flows for science that would enable researchers to conduct their research projects without needing to rely on centralized agencies, also to be incentivized to collaborate and share data, and to gain access to all the data and knowledge assets that are available, and also be rewarded for that. So I'm using a program called Token Spice, which is an agent-based simulator that was developed originally for the ocean community, but as Shadi said, it is very general. So so you can develop any agents that you want that have certain actions, and the individual agents are then connected within a file that's called a netlist, which determines how the agents interact with one another and what actions they should take, and they're passing different variables. And it's just it's best to think of it as an agent-based simulator. So the questions I'm asking with my simulations are mainly how many projects can be funded in each model. So when we have some grant funding agency, how many projects can we fund? Also, how many researchers out of a cohort of researchers that are applying for funding actually do get funded? Also, where does the value end up? So if it starts at in some treasury, does it end up in a centralized knowledge creator like the journal, or is it spread fairly across the community who are contributing to the whole ecosystem? And also, how much value is flowing back into the ecosystem? Because if we're talking about open science, we would like to have a more continuous flow of value rather than the linear system that we have now, where value is starting at one place and ends at another. And also, when value is flowing continuously, that means that more research projects can be funded and there is overall more utility. So with that, let's get into the first model that I developed, which is actually the model that should be representative of what's currently how science currently works in the real world. Of course, slightly simplified. So in this schema, each block essentially is an agent in token spice that I developed, and there is a grant funding agency which has a certain number of tokens that get distributed to researchers, and researchers then use that funding to either buy any resources they need and then to publish to scientific journals. And the key actions that researchers take is they create proposals, and proposals are essentially Python dictionaries with a bunch of different parameters, like the grant requested or the knowledge assets that will be created by this research project. So that could be an estimate of how big a data set will be once an experiment is run, or how many new algorithms will be developed, or any knowledge asset that can be created by a research project. And so whenever a new proposal is submitted, these parameters are randomized, and they are used to determine whether a project is funded or not. So this is a kind of a naive approach to funding, where a proposal that has the smallest ratio of the grant funding requested and the total assets that will be created wins the proposal. So a proposal that is requesting a small amount of money but will generate a lot of value is more likely to be funded than a proposal that is requesting a lot of money and doesn't really create that much value. And then each researcher also has a parameter that I call a knowledge access index, which in this case can actually be many things, but it's best to think about it as a number that is representative of your expertise in the field, so your level of knowledge. So the idea behind this is that whenever a researcher is able to conduct research, their level of knowledge increases, because research is the primary mechanism to gain new knowledge, to basically generate new knowledge. And the mechanism at play here is that when you have more knowledge, you're more likely to be funded again, because you have more expertise, so your proposals will have more merit, or I guess in this case it can also be thought of as reputation. But in the subsequent models, knowledge access is really only a number that represents the level of knowledge. So let's take a look at the graphs that were generated by this model. So the first column, the first three graphs are pretty much showing the same thing, which is that in the model where we had two researchers competing for funding, once a researcher won the first grant, their knowledge access index has increased, which gave them an absolute competitive advantage, meaning that they won every other subsequent funding in each funding round, even though that both researchers submitted the same number of proposals. So this is a kind of winner-takes-all mechanism at play. And I've run multiple iterations of this model, and sometimes it does happen that one researcher does get funding even without them being the first one to win it. But there is almost always a clear winner of all of the funding. We can also see on the graph in the bottom left-hand corner how value is slowly being depleted from the treasury, which in this case it's a university, but it might as well be called just an external grant funding agency. And from another run of the model, we can see how, which is in the bottom right corner, we can see how the value flows from the treasury directly to some centralized knowledge curator. So it is this kind of linear system, and there is this winner-takes-all mechanism where one researcher, if one researcher wins the funding, that basically means that they're going to win every subsequent funding, and the other researcher is unable to conduct any research. So this model definitely has a number of limitations. First of all, it's definitely an oversimplification of the real world, because there are definitely more parameters that are determining whether a proposal gets funded or not, and there are also external parameters that I can't really model in TokenSpice. Also, the parameters within the simulation itself are fixed in this model, so the number of researchers is fixed. Also, we are not, there's only one type of knowledge asset, even though a research project can generate different types of knowledge assets. Also, the prices are fixed, so whenever a researcher is spending tokens to buy the resources they need for their work, those prices are also fixed. And lastly, I have not yet validated this model with real-world data. That's something I am currently looking into, trying to validate the mechanism that we see in the graphs, this winner-takes-all mechanism, and this value flow with real-world data. I'm currently looking into NIH funding records, which do show that if you've been given a grant before, you're much more likely to be funded in the future. But that's currently a work in progress. So the next model that tries to improve upon the baseline is a model that basically takes the centralized knowledge curator and makes it into a decentralized knowledge market. So the funding mechanism is exactly the same as in the previous model. There is an exhaustible treasury that funds research projects. Researchers are competing for funding. They submit proposals. We are still tracking the knowledge access index, but this time there is a decentralized market where the researchers publish all of their results, and they keep ownership of whatever they produce, which is allowed by Web3 technologies and the advancements in encryption, so that researchers can publish data sets that can be encrypted, for instance, so other people can still use those data sets without really knowing the data. So this provides an incentive for the researchers to really publish everything from the research, and maybe publish that continuously even before the research project is actually finished. And what this leads to is a much more continuous value flow, where once a researcher publishes data to the marketplace, they can reap benefits from that data after the research project is finished as well, because another researcher might come along and they might want to buy access to that data. So they're buying from the knowledge market, and the knowledge market then gives the rewards back to the researcher that owns that data. So it's a kind of passive income stream, let's say. And also, anytime a transaction is made in the knowledge market, the knowledge market collects fees, which are then distributed back to the treasury and also to external stakers. And the stakers are basically community members, which are staking tokens and providing liquidity in the market. But they are not really that important in the model. It's they're included in the schema and in the simulations for completeness, but we are not really concerned about the stakers at the moment. Also, one last thing, since this is a decentralized system, we are assuming that the researchers already have some tokens in their wallet. And since we have a decentralized knowledge market, anyone can buy into the knowledge market to gain any knowledge they might need from the research that is being conducted by the other researchers. So in this case, where we have two researchers, if one researcher gets funded, the other researcher can buy into the knowledge market to see whatever the second researcher has produced, and that way the knowledge access index stays the same for both researchers. So we no longer have, since we no longer have the value of the research locked within some centralized knowledge curator, the value can be shared among everyone. And we should not have this winner takes all mechanism where only one researcher gets funded, but every researcher should be funded eventually. So if we take a look at the graphs, the graphs on the left clearly show that that the winner takes all mechanism is no longer at play here, because both researchers have been funded more or less equal amount of times. One researcher was funded 10 times, the other one 9 times, and we see the key graph here is the knowledge access index on the right there, and the knowledge access index stays the same for both researchers. So this is clearly an improvement from the baseline model, and I guess the moral of the story here is that sharing data does provide more value. Some other graphs, we can see that the DAO treasury is still depleted eventually, and since there are only 2 researchers in this model, the fees that are collected by the knowledge market and sent to the treasury aren't really enough to create sustainability in the long run. So there is still finite number of research projects that can be funded, but we see that on the top right graph, researchers are being rewarded for publishing their knowledge assets to the knowledge marketplace, because we see that their personal ocean is the token that is being tracked here, is increasing over time, which is because every time a researcher gets funded, they use that funding to get the resources from the knowledge market. So we are assuming that everything they need is already within the knowledge market, and they just need to buy it. So that kind of replaces the salary that researchers would normally get from being employed by a centralized institution like a university, where apart from doing research, the researchers are also teaching, for instance, and they're getting a continuous salary for that. So this kind of solves that issue. The bottom plots are showing the value that's locked within the knowledge market and the fees that are collected with the knowledge market. The bottom right graph, on the bottom right graph, the value of the knowledge market isn't really, it says that it's an ocean, but what that means is just the value of the assets that are locked within the knowledge market. So this value cannot really flow anywhere. That's just representing the value of the assets themselves. So actually, in this model, I've added the functionality that we can have an arbitrary number of researchers. So I tried to run the simulation with 100 researchers, and that produced some interesting results. So I forgot to mention that every researcher starts with 10,000 ocean tokens in their wallet, and whenever they are not funded, they buy the assets they need and the assets cost 1,000 ocean. So actually for the first 10 rounds, since there are 100 researchers, 100,000 a percentage of 100,000 ocean is fed back to the DAO treasury. So the slope is very close to zero, but then it declines really rapidly. So when there are 100 different researchers, the majority of them don't get funded. Don't get funded because since we are only funding one proposal at a time, they lose all of their tokens before they can get funded, and then they simply don't have the knowledge access index that's necessary for them to remain competitive in this space. But still, there are quite a lot of researchers who do get funded and who do get quite a lot of rewards. And we see that the simulation was running for 30 years, and the DAO treasury ocean was not depleted. And 30 years is quite a long time, I suppose. So speaking of one proposal at a time, another iteration of this model that I developed was enabled multiple proposals at a time. And so this is the same model, just with multiple proposals being funded at a time. And in a simulation that I ran with 5 researchers and 3 proposals at a time, the DAO treasury was being depleted quite quickly, as one can assume. But still, researchers were getting funded, which is the important bit. And even though some researchers have not been funded that many times, all of the researchers ended up better off than when they started. So on the right plot over there, the blue researcher ended up with more tokens than they started, even though they haven't been funded that as much as, say, the green researcher. I also these are plots showing the same simulation, but with 10 researchers. There isn't really much of a difference. The treasury is still being depleted quite quickly, but the slope is slightly skewed, so it's depleted slightly slower, but still it's a very linear relationship. And in this case, some researchers did lose did end up worse off than they started, because one researcher got funded only once, so they spend most of their time just buying into the marketplace and not really getting that many benefits. So since we had this in this model, each funding round was at a fixed time scale. So after a fixed amount of time, new funding was disbursed, which is probably not the best idea for a decentralized marketplace, decentralized funding mechanism, since each research project takes different amounts of time to finish. Some research projects can take years, some only a couple of months. So we really want to model that as well, which leads me to another iteration of the profit-sharing model, which enables rolling basis funding. And the results are and we still have multiple proposals funded at a time. And the results are very, very similar, except that now the actions of the individual agents are not really dependent on time, but rather on the actions of other agents. So that adds a bit more complexity. And also, just out of interest, I added a functionality for the researchers to be able to randomly buy assets from the marketplace. So that was just to see what would happen to the simulation if we added another degree of freedom. I'll show you what that did to the simulation in later graphs. These charts so far don't have any random buying enabled. The top graphs here are probably the most important, because actually since we have multiple proposals being funded at a time, this actually means that when I am the researcher that was not funded in the first round, I now have 3 different research projects that I can sort of buy from the knowledge marketplace, and I can gain 3 times as knowledge access index as than the people who are actually doing the research. So if I'm a researcher and I have been funded, my knowledge access only increases by 1 point. But if I have not been funded and there are 3 research projects that have published to the knowledge marketplace, I can spend 3 times as much tokens, but I can gain 3 times as much knowledge. So that actually means that in this model where there are 3 proposals funded at a time and 5 researchers, that means that all researchers are guaranteed to be funded, because once the first researcher finishes, the researcher that has not been funded previously has a much higher knowledge access index. So they're pretty much guaranteed to be funded regardless of what random parameters are chosen for the assets generated or the size of the grant. So this model actually ensures that researchers will eventually get funded, and we can see that all of the researchers are benefiting from this. So even though there is somebody who had the most ocean in the end, it's the ocean of the researchers is very similar, and everyone is reaping the benefits of participating in this decentralized marketplace. With random buying enabled, that was an experiment that didn't go as well as I would have hoped, because basically at each time step, each researcher had a probability of buying an asset from the knowledge marketplace. So I initially thought that would lead to more sustainability in the long run, but what that actually meant was that after the treasury was depleted, its value kind of started fluctuating, since the buying actions, since buying from the marketplace does not really take that many tokens, so the fees are actually very small. So it's not enough to it wasn't enough to really fund more projects. But it was an interesting experiment, and what it did to the graph of the researcher ocean is that it made it completely unreadable, and there isn't really much insight from that graph, because again, researchers are getting rewarded for publishing to the marketplace, but if at every time step they also have a probability of buying from the marketplace, then their ocean is kind of fluctuating. But we can still see that both the staker and the knowledge market are overall growing, which is also what we want to see. So the knowledge market is still encapsulating quite a lot of value from the knowledge assets that are generated. I think in this experiment it was with more than 10 researchers. So actually some researchers weren't funded in this experiment, but it's still the same model as before. So the last model that I wanted to share with you is a much higher resolution profit sharing model, where the treasury only funds public projects. And so I don't know if you can really read what's on the schema over there, but basically the top loop is the profit sharing model as before, but then there are these other loops, and basically there are 2 types of researchers now. There is a private researcher, and then there are public researchers. Public researchers are submitting proposals, they're competing for funding, and they're receiving funding from the DAO treasury. However, any research assets that they produced are not owned by them, but are rather published to the public knowledge market, and they are treated as a public good. So which doesn't necessarily mean free, it just means it's a lot cheaper than the private market. but those researchers, the grants that they receive should also cover their costs of living, let's say, because they will not be reaping any benefits by publishing to the knowledge market. Also, this model is higher resolution than the previous model by having 3 different types of knowledge assets. So there's data, algorithm, and compute services, and each researcher can only publish, can only produce one of these 3 assets. So a data provider is a researcher that runs experiments to collect new data. An algorithm provider can be thought of as a theoretician, let's say, that is using data to create new algorithms. And a compute provider, that's exclusively a private researcher agent, and that can be thought of as a private research organization that has a lot of data that doesn't really make sense to publish to the market directly, but instead what they are providing in the market is compute services on that data. So since we are thinking that even large organizations could benefit from the decentralized knowledge market, say there are knowledge assets that they don't have and want to take a look at, they can also receive additional benefits by publishing whatever they have. So in this model, we are assuming that private researchers, also, since they are conducting their research on their own, have more tokens in their wallet than public researchers. So, and also the private publishing to the private market is more expensive than to the public market, and the assets themselves are more expensive, and different assets have different prices as well. And so there are a lot more degrees of freedom in this model. So if we take a look at the graphs, actually this model has been the most successful in terms of sustainability. So the DAO treasury after 30 years has went from 500,000 ocean to slightly less than 300,000 ocean, which is the best so far. Even though it's still decreasing quite linearly, it's the most sustainable, and it's only with 5 researchers. So in one of the previous graphs that I shown, the DAO treasury wasn't depleted, but there were 100 different researchers. Now we have only 5, and after 30 years, we are still able to fund public goods. And so in this model, we have five researchers. 2 of them are public researchers, and 3 of them are private researchers. I think researcher 0 and researcher 1, so the purple and red ones are the public ones, and the other ones are private. And another thing that we can look at is the value of the private versus the public market. So the private market, as expected, is more valuable than the public market because the private assets are more it's not sufficient to say that they are more valuable than the public assets, but it is more costly to publish them to the private market rather than to the public market. However, the fees collected from the public market are higher than the one from the private market, simply because everything that's in the public market belongs to the DAO. So when we're buying from the public market, we're basically sending that ocean straight to the DAO treasury or to the different stakeholders. But in this model, I got rid of the staker agent because it wasn't really relevant to the objectives of this simulation. So before I end this, I just want to give a quick overview of my plans for the future. So firstly, I want to validate the baseline model with real-world data. So right now I'm looking into NIH funding data, but if anyone has any suggestions on some other data sets that I can use, I'd be really grateful for that. And then I want to run 3 different models. First of all, since the public funding model has been the most successful, I think it's good to explore that a bit further. And thinking about the limitations of the models, since we always have a fixed number of researchers, which isn't really realistic. Like, what would actually happen is, as more value is being locked within the knowledge market, that would attract more people, because more people would see, oh, this market has a lot of value, maybe there's something I can use as well. So more people would be coming to the space to become public researchers or private researchers. So I really want to simulate this growth of the community, and that simulation will inevitably lead to questions about the price of the token. So right now everything was modeled with the ocean token, but that's really just a variable name. Like, it might as well be called the Opscientia token. But if Opscientia actually had a token, we do need to ask what the price of that token will be as the community grows, and if we have some kind of a minter, how should that be distributed, and what does it do to the value? So, to the value of the token, because if there are hundreds of researchers within the space, we don't want to suddenly mint new tokens that will delete the value of all the researchers' tokens. So that also begs the question: how do we distribute the new tokens across the community? Should it be distributed just to the DAO treasury and then to the public researchers, or should it be distributed across all stakeholders? Those are some questions for this model. And then lastly, I want to develop new agents that would represent community agents that are voting on which research projects should be funded or not. So right now, the funding process is very algorithmic. It's just a very basic function, but in reality, we don't want the DAO treasury to be like this centralized entity that decides which researcher gets funding, but rather we want the community to decide. And each community member will have slightly different incentives. So I'm thinking that there should be multiple community agents with who want slightly different things, who are optimizing for either their own ocean or something else, and that way they will vote slightly differently, and then there are and that creates this community voting model. So yeah, that would be all for this presentation, and I'm happy to take any questions.
Thank you, Jacob. Thank you so much. That was an excellent overview, very eloquent. You really were grappling with some pretty complex ideas and concepts, and I thought that you were able to communicate those really, really well. So just to kickstart the conversation, I can for sure, I have tons of questions on my own, but I'm sure we could talk about those offline. But just to kickstart the conversation, I'd like to pose the question out to the community. What does a successful decentralized grant agency look like to you? And kind of considering how this fits into the work that Jacob is doing. So if that's a question that you feel interested in, please feel free.
I would like to speak on this. So I am a research programmer. That is my job description. So half of my job is writing software, half of my job is doing research. And I mean, you have some pretty good fundamental tokenomics, stakeholder buy-in, money going to power the network, et cetera, and so forth. A key element to really achieve the network effects of making it successful, I think, would be integrating something like peer reviewers, people to validate, whatever research is being submitted. Basically, I saw like the H score. I saw a hint of this person has been cited n number of times, or this sort of research has been used n number of times. But what I would like to see, and what I think would really make this already excellent idea, and very, very well explained idea is definitely a way to get peer reviewers and to, I guess it's sort of a chicken and the egg problem, but I think that was what I was missing. Otherwise, excellent work, excellent framings. Also, I appreciated the progression of the models. Great work.
I
Yes,
had a
please,
comment
Ben.
also. First, I just wanted to say that I'm brand new to this community. Someone pinged me about it yesterday, and it's very exciting. I was super impressed with your talk, and I agree with Neil that the way that you laid out the progression of models was great, and I thought it was really fun. Thinking about funding science in this decentralized way, I think coupling your DAO treasury to, if you all are familiar with the Gitcoin model, is a quadratic funding model where you could have the DAO treasury as a matching pool and then have some sort of like philanthropist component where people can choose what projects they want to fund. It's more of like a private funding mechanism. And then you wouldn't maybe run into this problem where the DAO treasury is always running out of money. Eventually you have new money coming into the system. And there's a component where people, like individuals, get to decide what they want to fund. And then I agree with Neil that you could have a peer review component on top of that, where maybe the DAO treasury allocates funds in certain places, but those funds get locked into a contract until the proposal passes peer review, and then it gets triggered, that project gets funded. And if it doesn't pass peer review, then the funds go back to whoever contributed, as if they never donated, because that project didn't pass peer review. But I think this is super cool. I think we should continue to talk about some of these ideas.
Yeah, that's really interesting. I hadn't really, we've just been so focused on thinking about the individual agents and thinking of the scientific ecosystem at large in this abstract modeling framework that we hadn't really considered, good ways of tapping existing Web3 ecosystems to fund the treasury. Like most of the work that we've been doing was kind of along the lines like, all right, well, this is probably going to end up being a hybrid model where once every 5 years, we renew an NIH or NSF grant that kickstarts the treasury a little bit. And effectively what we've done with this modeling scheme, and hopefully we can continue to do better, find this right balance of fees versus carrying capacity versus award schedule, find this really kind of like nice intersection between those parameters where the treasury does remain self-sustaining until that next round of external funding comes in. I think, yeah, Ben, thanks for such a great idea. I think like tapping Gitcoin to kind of bridge those gaps, because we can't always rely on a single source of funding, as we've seen through the baseline model, right? Unless we get a lot of institutional buy-in or reputation, those things aside. But diversity of sources of funding, I think, is going to be key for science, and it's something that science charities and funding agencies that aren't governmental have been kind of wrestling and dealing with. Yeah, that's really, really great feedback, and I'd be excited to know what Jacob thinks about it as well.
Yeah, I think that both quadratic funding and peer review are some things that we didn't previously think about for this model, and something that actually makes a lot of sense. Especially for like peer review, I guess that would add another level of complexity to the model, so it would be more high resolution, more realistic. That actually, well, some proposals won't even pass peer review, and I guess that also leads to maybe modeling the success of the research, even if it's funded. So like some research projects might not actually be like as valuable as others. So maybe that could also mean that if I'm a researcher that got funded, but my research isn't really useful, maybe maybe that could also like be recorded in my like track record, and I would be less likely to then get funding in the future. So yeah, I think there are a lot of these higher resolution models that are really interesting, and quadratic funding quadratic funding as well. I'd be interested to see how many like how much external funding we would need, like how many private agents would need to come on board to make this as sustainable as possible, because I suppose that we are basically optimizing for sustainability in the long run.
I think you might be surprised at how many people would be excited about an idea like this. I think projects that kind of get rolling, like, oh, maybe we'll get some money, then all of a sudden they have millions and millions of dollars in their treasury. I just saw another person comment about retroactive funding in the comments, and I just wanted to speak, kind of say something about that and elevate that. Oh yeah, you're here. Yeah, you should just say it yourself. But I think that's a good idea.
Yeah, I was since you mentioned the Gitcoin thing, right? So they're also spearheading this idea of retroactive public goods funding. So I was thinking something along the lines of basic science research that proves to be extremely useful in the future, but it's not clear right now. So maybe in the future you get something like government grants or projects downstream of some research that had a great impact on the field as at large. So I was thinking maybe we could factor that in somehow.
Yeah, I think also one thing that actually comes to mind is since with Ocean's data tokens allow data to basically be treated as this financial object, I guess that entire research projects can be treated like that as well. And if we open scientific research to like the speculator market, I guess that could result in some really that could lead to some really weird places where people are basically speculating on the value of scientific research, which basically creating like a stock market for scientific research, I suppose.
Which could have really great and really bad things associated with it. So a little bit of trying to catch lightning in a bottle there, I think. Yeah, and I find it really interesting. I think, NIH, NSF, other public funding agencies, I think they have a lot of, just speaking from the perspective of an academic here in the States, I think they are really interested in meta science and how to optimize their procedures for awarding funding, because they have these arbitrary performance reviews sometimes that they have to meet. And I think it'd be really interesting to kind of see a Gitcoin type pool, right? Something that's just spun up spontaneously within the community that shows as a proof of concept to NIH these alternative funding mechanisms, and showing that, we selected 10 researchers from around the globe. We employed this quadratic funding with these limited funds, and look at this amazing work that's come out of it. How about you guys match us, right? How about you provide a matching pool for this next round? I think there's a really strong narrative there. But yeah, I think it definitely depends also on the community, the diversity of the community, the ideas. And so that's why, we've been pushing a little bit more on this DAO affiliate program, right? Where Opscientia isn't necessarily the open science DAO, the only one. We're just providing this framework and technological stack for people to get together and coordinate. And so, we're talking with other DAOs like Planetary Resilience DAO. There's Active Inference Lab. There's 2 or 3 other ones that have kind of come and gone. So, thinking of ways that we can leverage the expertise in a decentralized community to really tap into these funding sources that other traditional organizations can't, because they might be hiring people that all fit a certain, profile or whatnot. So I think our strength comes in diversity, especially when it comes to areas that might be notoriously underfunded or not paid attention to as much.
So Jakob, what are your next steps?
Yeah, so we've been talking with Shadi about the possibility of making this into a like drafting maybe an actual like research paper or a more in-depth report. So for that, I definitely need to look more into the actual like real-world data to at least validate the baseline model, and maybe also improve on it as well, because the baseline model was only running with 2 researchers, but then in the subsequent models, I was able to run it with an arbitrary number of researchers. So adding that functionality back to the baseline model. I did hear some feedback before that with these profit sharing models, the Web3 models, it's harder to validate those because there isn't that much data. Like the data that we have, we can see how Gitcoin is working, and Gitcoin is definitely something that provides a mechanism, a funding model that is already validated. But I would say that Gitcoin is slightly different than a scientific model, because, well, Gitcoin is only really tied to software, whereas science goes beyond software, and there are many more things to consider when funding scientific research. As you also said, peer review. I don't think that Gitcoin really has like a peer review system. So yeah, validation of the models, and then developing higher resolution models that would improve on the existing ones. So actually, I think peer review and quadratic funding should definitely add those on the list. And then apart from that, also tracking inflation. So these models so far have not been tracking the value of the tokens, but inflation is an inevitable part of any value flow. So tracking the value of the token itself, tying that more to maybe the value of the dollar, let's say, so that it's also more relatable to people who are reading about this. And then also, as I said, community voting for determining what proposals should be funded. And yeah, overall increasing the resolution of these simulations, making them going from the top level view more towards really what are the incentives of every single stakeholder, what are all the possible stakeholders, what are they doing, and what are they optimizing for, and how do we design the whole system so that even if there are maybe malicious agents, like let's say the publicly funded agents, researchers, we could have a malicious public researcher agent who just takes the funding and then doesn't contribute to the public market. So also testing that. So like really testing whether the community is protected even against malicious actors.
Yeah, that's great work, Jacob. It'll be really interesting to see all these pieces come together as we try to figure out what does a resilient, decentralized science market look like that funds open access and public goods. I think there's a lot of really, really interesting stuff coming up, but we'll save those for a separate conversation because we're over. If anyone here today would like to qualify for a POAP, please do fill out the survey, contact me if you need the link. And lastly, if anyone's interested in potentially being a mentor for future Open Web fellowships, also just shoot me a ping on Discord. All right, cool. Well, I'm going to sign off and get some breakfast here. And I'll see you guys later.
Thanks,
Bye.
everyone.
Thank you.
Thank you, guys.
Bye.
See ya.